Let's start. My name is Mika Uina. I'm from Blue Robotics, one of the founders, and we are today here to tell you about our project, Blue Robot. That's the most affordable platform available currently, and because it's most affordable, you can buy it, you can have it, you can build it, and it's going to be open source. We already published GitHub links, everything's on our website, so free to go and see. And that's pretty much it.
Yeah, I'm mostly an embedded guy doing electronics and embedded code, but in this project I have been doing quite a lot of software as well, even though that's not my special expertise. Anyway, let's start.
So the software is fully Signal version 2. You can find it in GitHub. And the hardware, of course, everyone is interested about how we license that. The answer is we don't know. And we are not keeping too much hurry with this because it's not finalized yet. We have new versions coming, it's developing all the time. We have to log in what we're going to produce. And the 3D sensor is the hottest thing we have because nobody else has it. Okay, and we found a new way to make a 3D vision around machine 360 and 110 degrees vertical. And you're going to see the demo after our presentation. And this is called for participation. Like somebody's been telling that we are mostly hardware guys, that's true. And we need software to make this thing. Making a robot, affordable robot, big thing again. Why we did this? We did this because we needed it. We needed it for ourselves. And we actually checked different options, and the prices were from 20K to up to 60K. And they didn't do the job we wanted. We have a small warehouse, we have around about 30 customers, and we didn't find a solution. And we built this one. You can see the picture in summer 2016. It's a bad picture, you can find it from the web page. It was actually a remote control toy. It was working, but nobody could actually use it because of lagging network connection. And we decided we need autonomy on this project. And I wrote these design principles. It has to be simple, robust. It must be capable of taking whatever comes to it. And manufacturing must be very easy, so we can make as many as we like. We probably need 10 or 20 of these. And cheap electronic components, we evaluated everything you can get from China, and it didn't work. And it has to be autonomous, do tasks we did, and able to map surroundings, because we don't have time to map things, and surroundings are changing all the time. And by accident, we found out this way that we made it a platform, that there's an application layer. I tried to draw all sorts of different solutions on this system. It was like a tower, and you see those codes robot makers make. We tried to make something like that, and it didn't work. So I decided that we make first a platform, and then we decide what we do with that. And that's actually something that we found out to be a good solution. So the platform is the product, and the integration is simplification. That has to be very simple, and because everything is integrated, it's very cheap to manufacture. And this is from Wikipedia. Definition of autonomous robot. It's mostly the same thing I figured out myself. It has to be able to gain information about the environment, learn, work without human intervention, and move through the space and not harm anyone. Now comes the big thing.
The breaking news. We don't use ROS. But we are going to support it, and we are going to need some help for that. And maybe I'll tell the reason why. Because we looked at what others have been doing using ROS, and we looked at the typical robot. they buy a lot of these expensive modules and build the robot using these blocks. And it's quite easy. You can just go and buy these off-the-shelf components. Then you do the robot, but the problem comes here. These expenses add up, and then you have a bill of materials from 5,000 to 10,000 K, and then you need to try to make a product, and so you on top of it, and it's going to be that typical 30K robot. And then you use in the background that during firing image, that's the LOS, the glue between all these modules, and you are going to convert all kinds of sensor data through USB bus, and then you need this message passing and all kinds of stuff. And it's nice when you want to do coding for your life. I think there has to be a better way. And being an embedded guy and electric designer, I integrated all of it in a single board. And the great thing is it gets so much cheaper. And then all the low-level sensor stuff is done on this STM32 microcontroller. And well, it costs a few bucks, and it can process all the data, and with very low latency. So we get sensor data very accurately and very quickly. It's great and it's cheap, and it's less cost to maintain. And then I made the first version of this board in about 6 weeks, and designed from scratch. And then this is the second provision. This is an actual product produced in China. This one. But then we went on the SLAM project. This is simultaneous localization and mapping, and it's a very big question in mobile robotics. And it has been analyzed academically for decades. And it's problematic because we want to localize, we want to get the coordinates of the robot, and we cannot use GPS because it doesn't work indoors, and even outdoors the resolution is very poor in urban environment. But we need to know where we are, but we don't have a map. And to build a map, we need to know where we are. So we just start building a map, and all the errors will accumulate. So this is a difficult problem. And the problem is there hasn't been much open source involvement in solving this. For example, with ROS, everyone's still using G-mapping, which is a demonstration algorithm developed by real scientists 10 years ago, and it's a great algorithm, but no work has been done on it. So we thought that we need to learn how to do this, and right now our SLAM algorithm isn't anything special, but it's usable, and we are going to develop it further. And that's great because we have all the sensor data. If we have problems with our hardware, we just change our hardware. We are not locked in to any other hardware. So this is an example map after about, I think it was 4 months after we started from scratch, and I coded the mapping layer in about 2 weeks at that point. And there is also route planning going on here. So the robot has automatically explored my parents' house in this picture. And well, after it has done this automatically, it's moved around and brought it back, then you can go there and it will decide the best route. And if you try to prevent it, go between, then it will reroute and things like that. And we have another example from yesterday. We went to that J building, and that's the map we got by its own there. So with this actual machine. And people thought this is some kind of lost car. They didn't even realize this is a robot. They tried to stop it and move it, and it's quite fun. And then you try to move it, then it's powered, it will push back, it will try to keep its position, and people are very surprised.
Yes, so we are stunned. Did we do something new? To find out, we went to South Korea, Robot World 2007 there, 2017, in September last year. And we just wanted to know, is there anyone doing the same thing? And maybe we probably didn't find everything from Google. And what we found out is that nobody else knows how to do the thing. And people were actually lining up on our booth. And they were complaining after 2 days that they haven't been able to talk to us. And then we found out we have done something unique. So maybe we should keep this out as open source. And that's what we do.
Yeah, so our next steps. The basic hardware is pretty good, I think. We are going to do a minor modifications to make it even better, but no big changes there. And then there is the counter-tracking 3D sensor. I'm going to talk about it in a few minutes. We are manufacturing small batches. We made 30 of these in PCB. This is one of the 30 programs we are right now making. We are making the batch size bigger and bigger and making small changes. And we are open sourcing all software, every single line of software, and well, as we said, all the hardware licensing is unclear. It's clear that we will give all the schematics and everything like that out, but we've not decided about the actual CAD files yet. And we need application development because our great idea is that we develop a platform only. So our platform is the smallest component. Instead of a sensor, our component is the full platform. And that makes it quite easy to develop your own application. And this is the delivery boy application here. It's like a demo of the simple possible application. It's a passive application right now. It's just aluminium. This will have a few cameras to make it even more usable. So, to make it affordable, we have put the price down so that it costs about 1,200 euros to build this. So we are selling it out at 3K right now, and
we need to have some money to keep this rolling.
Yeah, and then we are going to publish a smaller one, the S model. And for that we are going to give a developer special where we are not going to make any profit, basically.
Yeah, basically the 999 offer we offered you today is something that we are not sure that we actually make money at all.
Yeah, because we need this to go out and for people to find this and start building the ecosystem. The software architecture, I know many people here are interested in software. It's right now it's all done by me, 99% in C, 35,000 lines. About half of it is firmware in STM32 microcontrollers, and no any kind of error is left. And, well, very few dependencies, and that's for a good reason, because I only use libraries when I need to. This is on our website, just an example of the project that you will find on the GitHub. Because we have the firmware projects, and then we have a Raspberry Pi inside this machine doing that mapping, SLAM, and the root finding and communication. That's one of the projects. And then we have prototype user interfaces. We are going to replace them with properly done versions. But let's get back to where we were earlier, because this comparison is a little bit unfair, because you see in the middle of the ROS version is this expensive SIP LiDAR, that the laser scanner, that hugely expensive part. There are some cheaper options, but that's often used in robots. So we need our own sensor, and then that's our magical groundbreaking 3D time-of-flight sensor system. And we are going to, this actual robot has a LiDAR, rotating two-dimensional laser plane sensor. And it's not good enough because, as you can imagine, when we have tabletops, this will hit them. You cannot see, we can only see at this 2D level. And that's why we need a sensor. And 3D time-of-flight isn't that new, it's a decade-old technology. So we take this normal laser scanner, which takes 1 pixel at a time. It measures the distance by using the speed of light. But instead of a single pixel, we have a full sensor with 10,000 pixels in it, and so it can produce a cone like this, or pyramid shape. So it produces a point cloud directly. And that means from our current 500 2D samples per second, we are going to get 500,000 distance measurement per second in 3D like this. And we are going to replace all of that sensors with this one single technology, the FOSDEM. And these 3D cameras have been available to sell for quite some time, but they are either stuck or they are really expensive. And we are going to bring the cost down. So I'm going to give you a demo effect. Hopefully it works. So let's say the cables are connected and turn the beam on. This is a slow frame rate right now. This is the prototype I'm developing with. Yeah, so the distances are actually color encoded in that image. You can see, for example, I'm green right now, and when I go further back, the color shade is more towards blue. So you can, for example, see your own text in that picture, and you can measure the distances. For example, this point 2 here, see 2.5 meters, it says that one I just moved there. And now PK is down to 1.6 meters. So yeah, that's kind of technology here. And this technology has some drawbacks. It suffers from some issues like gray light. If I put my hand here, you can see the background image corrupts there. A red dot there showing it's very close, even in reality it isn't. So we just published a white paper on our website because we have some unique ideas how to fix these issues. And instead of patenting them, we are going to give them out freely to prevent all that patent trolling. We don't want to be a part of that. So and if you want to see a better demo, come to us afterwards and we will show it in more detail. Still. So yeah, this is basically our sensor. It's a little bit big right now, but this is being manufactured right now in China. We hope to get them before the Chinese New Year. It's a smaller version.
Yeah, I have to fill up here. It's like the current sensor would be like 40 times 40 millimeters, and it's much smaller. This is the very first one we ever made, and because Chinese New Year, we are lining up with the manufacturing line, and hoping that we will get it before the 16th this month. And if we get it, we are able to produce more robots, the first ones with what Antti actually didn't tell that we have 10 of these sensors around the machine providing 360.
Yeah, exactly. This
is the image on the background.
Yeah, because we can do this sensor for about, it will cost about 30 euros to make it for us. And so we can put 10 of them and it's 300 at that point, and it's still cheaper than the cheapest we do the radar we are using right now. And You can see that image on the back. When we place the sensor like that, we get full 360 degrees by 120 or 110 degrees that way.
See the white paper on the web page. It's fully explained.
Yeah.
Yes, let's make open source robotics affordable again. I've seen raw solutions. Everyone's telling me it's $10,000 to make one. Participate, whatever you can do, it's good. And the price, like I told you, is very cheap now. We hardly make any money by selling it that price. But what we want to offer you is a handout, sort of. That you get the technology to your hands, you see what you can do with that. And unfortunately, we are unable to deliver before June. And that is 4 months away. Roundabout. And on the first thing at our webpage, there's a link where you can make the order. And there's also the developer survey. If you want to participate, you can leave your email and we'll contact you.